Hey class. Alright, so today what we're going to do is learn about the Pythagorean Theorem. So this is dealing with right triangles. And the way that we label our right triangle is this going to be leg 1 or leg 2. This is leg 1 or leg 2. Just know that both of these are your legs, and the side opposite the right angle is your hypotenuse. The hypotenuse will always be your longest side of your right triangle. And then we use the Pythagorean Theorem, which is this relationship that we have here. So leg 1, the square of that, so if I drew a square out there, the area of that plus the area of the square on leg 2 is equal to the area of the square on the hypotenuse. So leg 1 squared plus the length of leg 2 squared is equal to the length of the hypotenuse squared. We'll use that relationship to find some missing values on some right triangles. So our first one, we don't know what x is, and x is going to be the hypotenuse because it's opposite the right angle. Alright, so our leg 1 is going to be 2, our leg 2 is going to be 4. So I plug that into my equation. That 2 squared plus 4 squared is equal to x squared. So I simplify that, that's 4 plus 16 is equal to x squared. 20 is equal to x squared. And then I got to get rid of that square. So what I'll do is I'll take the square root of both sides. So my answer, x will be the square root of 20. Now you're more than welcome to leave it as the square root of 20, or you can plug it in your calculator and get the decimal approximation of that answer, which would be around 4 or something. Alright, this one, now we're missing a leg. We don't know what that leg is, but we know the hypotenuse is 10, we know that the 6 is your other leg. So I set it up at 6 squared plus x squared equals 10 squared. And we simplify it just like a normal equation. So 36 plus x squared equals 100. I subtract my 36 from both sides. X squared equals 64. Take the square root of both sides. So x is equal to 8. Alright, so that would be my missing side for this triangle. Alright, then the last thing we want to do is use that Pythagorean Theorem relationship to figure out if these lengths are right triangles. So we've got 3 lengths of a side, and what we want to do is we want to check to see if they're a right triangle. Now remember at the beginning we said that the hypotenuse is the longest side, so in this case 5 is our hypotenuse, 13 is our hypotenuse, and 8 is our hypotenuse. So we want to check to see if those are true. So we've got 3 squared plus 4 squared equals 5 squared, and we put a little question mark to see if that's true. So we got 9 plus 16 equals 25, so 25 equals 25, and that would be a yes. Okay, so now do the same thing. 5 squared plus 12 squared equals 13 squared, so 25 plus 144, is that equal to 169? So we got 169 equals 169, and that would be a yes. Check this one real quick. So this is 6 squared plus 7 squared, is that equal to 8 squared? So 36 plus 49, is that equal to 64? So that's 85 and 64. Those are not equal, so that would be a no, that is not a right triangle. And then the special part about these are actually called Pythagorean triples. Pythagorean triple is whenever you have an integer lengths for your triangle, and remember, an integer is not a decimal. So like 3, 4, 5 is a Pythagorean triple, 5, 12, 13, 6, 8, and 10 is, and there are a few more. But that's it on Pythagorean theorem.